This is Haribabu from SNS College of Engineering, belongs to Computers and Design Department. Now the subject is about the basics of electrical and electronics engineering, first year, second some subject. Okay, Unit 1 Electrical Circuit and Measurement. The topic is 5 Principles of Moving Coil Measuring Instrument. Okay, I have two electrical supply as alternating current and direct current. Can I use same instrument for measuring two supply? Is it correct? First of all, no. The thing answer is no. First of all, for AC we are using an one kind of machines for measuring, whereas in DC it will be another machines. Actually, the same machines or same operating things we can't apply the things. We need to convert the things and we need to apply the things. So for measuring the things we need a particular devices. Okay, see here, moving coil instrument, permanent magnet type DC only. First of all, so that thing we can measure permanent magnet type DC only, whereas electrodynamometer type we can measure AC and DC. So the answer is we can measure both by using electrodynamometer type and AC and DC, whereas permanent magnet type we can measure only DC only. So first the answer I said was wrong actually. Okay, now you get, I think so. Maybe I just discuss the thing as you knew or not. Maybe you thought it is the answer is in most of the persons will understand that we will measure the thing only by AC and DC measurements, but different materials, but in single material also we can measure by using what the material electrodynamometer type we can measure AC and DC, whereas in permanent magnet type we can measure only DC type. So here the permanent magnet is mentioned here. Okay, PMMC we can see. Okay, principle: when a current carrying conductor is placed in a magnetic field, it is acted upon by a force which tends to move it to one side and out of the field. So when applied, it acts upon by a force which tends to move it, so one side and out of the field. That's what we are saying here. So the process is simple. When we apply a permanent magnet, that is here we mentioning here as, see here, M is a permanent magnet, PP is a soft iron, P is soft iron piece, soft iron pole pieces, and A is a soft iron cylinder, and C is a rectangular coil, B is a spring, spiral spring, and D is a pointer. So through this, when we apply the thing, the force will be acted and it will move on out. PMC is nothing about a magnet which will be moving in and out. That's the thing. Okay, deflecting torque. F is equal to Newton laws. Okay, B is a flux density in WB per meter square, and I is length or depth of the coil in meter, and deflecting torque is now TD is equal to force into perpendicular distance. NBB is into B is equal to NBI into I into B, that is NBIA into NM, that is Newton meter. Controlling torque is nothing about TC is equal to deflecting torque, so NC theta is equal to KL. When we apply the thing in between, that is a magnetic field, when we kept a rod, it will be deflected, as when it is approached it will be turned out. So that is a torque, deflecting torque. Comparison. Okay, let me compare. Advantage: low power consumption, the scales are uniform and no hysteresis losses. Disadvantage: so there will be a advantage point, whereas the disadvantage points are somewhat costly as compared to moving an instrument. So it is costlier one. So cannot be used for AC measurements. We not able to measure the AC measurement by the permanent magnet types. Friction and temperature might introduce error, as in case of other instrument. Assessment question: when a current is carrying conductor is placed as it is acted upon by a force which tend to move it to one side and out of the field, where I given the answer actually in first point itself. Just go through the slide and get the answer. Okay, and disadvantage advantage points are given, so let you try without seeing that slide and answer me. Okay, the session is over and we will try to accomplish the next session on next classes. Okay, thank you.